Section 12.3, double integrals and polar coordinates, video 6. In the previous video, we saw an integral that, if integrated in rectangular coordinates, forced us to set up variable limits of integration on the first integral because the top and bottom of the region was not bound by constants, it was bound by equations. By converting to polar coordinates, we avoided that and had both sets of limits of integrations be constants. However, that won't always be the case. It is possible to evaluate a double integral in polar coordinates with variable limits of integration. Specifically, if you have a region that is bound between two angles, in this case alpha and beta, but the radii are not bound by constants, in other words, they're not bound by arcs on a circle, but rather by equations. In this case, the inner radius is bound by the function r1 equals h1 of theta, and the outer radius is bound by the function r2 equals h2 of theta. Then when you set up your double integral, you have to integrate r with respect, you have to integrate your function with respect to r with limits of integration representing those two functions, defining the inner radius and the outer radius. So it's not always avoidable to prevent variables from showing up in the limits of integration. Sometimes you just have to deal with it. We'll take a look at an example where the polar integral is going to force us to have limits of integration as functions of theta when we're integrating with respect to r.